The simulation shows optimal airflow, ensuring passenger comfort.
We must adjust the tunnel configuration.
Established target.
Stay low and follow me. We're almost clear. Move quickly now.
Strategic placement here maximizes effectiveness while minimizing acquisition costs.
And the community impact data confirms that assessment.
We demand something be done about this noise. It's impossible to live here.
It's wonderful, isn't it? They did a great job.
230.9. Shaft excavation drills large diameter vertical passages from surface to tunnel level using raised boring. Shaft
lining installs concrete or steel reinforcement, protecting excavation from groundwater infiltration and soil pressure. Fan chamber construction builds underground rooms housing massive ventilation equipment. Chain motor and drive systems connect electrical equipment to fan impellers. Variable frequency drives enable speed control, adjusting airflow, matching demand, efficiently reducing energy consumption.
230.4. Acoustic treatment lines fan chambers and ductwork with sound-absorbing materials, reducing noise transmission to surface, preventing community disturbance. Vibration isolation mounts fans on spring isolators or rubber pads, preventing vibration transmission through structure.
Fire dampers install at strategic locations, automatically closing during fires, preventing smoke spread through ventilation system, while maintaining
Surface structures construct ventilation, building, housing equipment and access, and providing architectural screening. Designs balance functional.
Piston effect utilization harnesses train-induced airflows as trains compress air ahead.
Supply Air Introduction delivers fresh, outdoor air into stations and tunnels through dedicated supply shafts and fans.
Air handling units conditioned to supply air filtering particles, cooling or heating to comfortable temperatures before distribution.
Removing brake dust and outdoor pollution, our filtration systems protect passengers from harmful air contaminants.
Cooling systems combat heat buildup using chillers, cooling towers, and heat exchangers, rejecting
Dehumidification equipment removes moisture from humid outdoor air, preventing condensation on cool surfaces. Sensor networks monitor temperature, carbon dioxide, air velocity, and smoke throughout tunnels and stations, providing real.
230.32. Normal operations mode maintains background ventilation during regular service hours. Seasonal adjustments adapt ventilation strategies for summer heat and winter cold. Control algorithms optimize equipment operation. Train fire procedures vary depending on incident location. Stop train in tunnel requires different ventilation.
Smoke detection systems trigger automatic ventilation responses when sensors detect combustion products.
Override the actuator now. Max power to Sector 4.
Manual engaged. Increasing airflow.
Cross-passage ventilation manages airflow between parallel tunnels, preventing smoke crossover during incidents.
Stay close to me, honey. We're almost there. Keep moving, everyone. The exit is straight ahead.
230.45. Testing and commissioning verifies ventilation system performance, conducting airflow measurements, controls.
Fan is positioned. Start the ventilation sequence. Roger that. Engaging PPV. The pressure reading is stable, but the vibration is slightly high on Unit 4.
I'm checking the mount bolts now. This one was loose.
Preventive maintenance programs schedule regular inspections, lubrication, and component replacement, preventing equipment failures that could compromise passenger comfort or safety.
.51. Damper maintenance with actuators for chilling up. Filter replacement changes air handling unit filters, maintaining system efficiency and indoor air quality. 230.53. Motor testing verifies electrical systems performing properly, checking insulation resistance, vibration.
230.54. Control system updates. Maintain automation equipment. Upgrading software and replacement.
230.55. Performance monitoring tracks energy consumption, equipment runtime.
Energy efficiency improvements implement variable speed drives, scheduling optimization, and equipment upgrades.
Indoor air quality measurement campaigns monitor actual conditions, comparing with standards and design predictions.
Passenger comfort surveys assess thermal comfort and air quality perceptions, gathering user feedback, supplementing tech.
Brake dust accumulation concerns address particulate matter from friction braking. Enhance filtration and cleaning Outdoor air pollution infiltration brings urban air quality problems underground. Advanced
creation. Biological contamination control prevents mold and bacteria growth through humidity control and regular cleaning, maintaining health.
Odor management addresses musty smells and diesel fumes using air circulation, filtration.
230.64. Platform crowding mitigation uses ventilation, creating more comfortable waiting. 230.65.
Security integration coordinates ventilation with surveillance and access control. Camera coverage of ventilation structures deters.
230.67. Terrorism preparedness addresses chemical and biological attack scenarios. Ventilation risk is and drug. Pandemic response tap ventilation for infectious disease control and eye changes.
230.69. Climate resilience designs systems withstanding extreme weather.
230.70. Flood protection waterproofs low-lying ventilation shafts and installs flood doors, preventing water.
Maintain front and air intakes and antibiotics with shaft accumulation with airflow.
Storm preparedness secures surface structures and equipment against wind damage. Emergency procedures address power outages.
Expansion planning anticipates future system growth, designing ventilation with spare capacity and strategic locations, enabling.
Retrofit challenges address aging systems requiring modernization while maintaining continuous operations. Phase
Persussits. Historic system constraints adapt ventilation to older tunnels with limited space and difficult access. Creative engine. Multi-level systems coordinate ventilation across stacked tunnels and stations.
230.80. Express and local track configurations require different ventilation approaches. Express
230.81. Curve and grade considerations to fetch your air sense.
Cross-passage airflow prevents pressure imbalances between parallel tunnels. Properly sized and dampered connections enable
Underground river crossings create long tunnel segments requiring intermediate ventilation shafts. Underwater shaft construction presents special challenges.
Adjacent structure coordination prevents ventilation impacts on nearby buildings. Careful design avoids air intake contamination.
The ideal spot here is a red zone. And the community feedback on this parcel is negative. We should look at the secondary site.
230.89. Coordination with utilities avoids conflicts between ventilation shafts and underground infrastructure.
And so the noise mitigation strategies we implemented have been approved.
So the emissions are fully filtered?
Yes, they are. The ventilation is necessary for air quality.
We are concerned about the noise levels.
We've included noise reduction features based on your input.
Architectural integration designs additive surface structures complementing neighborhoods. Quality architecture
Dual-use facilities combine ventilation with other functions including parks, plazas, or buildings. Creative
2.36, 230.96. Cost management balances performance against budget constraints.
230.97. Lifecycle cost analysis compares capital investment against operating.
230.98. Funding sources include transit capital budgets, government grants, and public-private.
As you can see, we meet all building codes, fire safe, and environmental regulations.
Yes, everything seems to be in order. Approved.
Industry standards guide design following NFPA, ASHRAE, and transit-specific guidelines. Professionals.
Best Practices compilation shares successful approaches and lessons learned across transit agencies. Industry collaboration.
Research at Dynances study airflow dynamics, contaminant dispersion, and thermal comfort, improving understanding.
Dimensions change.
The European data highlights a clear trend in localized practice.
And comparing that to the growth in the Asian markets.
Performance benchmarking compares energy use and maintenance costs across systems, identifying efficiency opportunities.
Forecasting and unsafe equipment slip, preventing disrupting service. Digital twins create virtual system models simulating operations, operating design.
Smart ventilation implements artificial intelligence, optimizing operations, dynamically responding to real-time. Internet of Things sensors proliferate throughout systems, providing unprecedented
systems secure. .112. Disaster recovery addresses catastrophic failures, developing contingency plans.
Workforce development trains engineers and technicians in specialized ventilation systems. Ongoing education maintains.
The airflow calibration is critical for this section, as shown here.
Understood. We'll adjust the fan speed at the interface panel.
Professional organizations, including ASHRAE and transit associations, provide for knowledge sharing.
Certification programs validate technician condition competencies and performance towards complex systems.
This diagram shows how the ventilation system constantly circulates clean air.
So the air is always fresh.
That is wonderful.